Hello everybody and students of the Academia Hargeisa Universalis. This is the first ever lecture for the School of Physics in the AHU, which is headquartered in Masaalaha, on the outskirts of Hargeisa, Somaliland's capital city, and I'm your lecturer for the lecture. For the lecture, Mustafa Aw-Abdi, Chancellor of the Academia Hargeisa Universalis. And in this one, I will focus on the classical mechanics. The classical mechanics summarizes the notion of macroscopic objects from planets to projectiles using concepts like force, mass, and acceleration based on using laws and energy momentum conservation in the Euclidean space. It provides a powerful framework for predicting movement in everyday life, distinguishing itself from the quantum mechanics by ignoring relativistic and quantum effects. For example, like Lagrangian and Hamiltonian mechanics offer deep from mathematical perspective beyond simple Newtonian forces. Before we begin this introduction video, follow me to my YouTube channel, subscribe, click the like button, write down comments about your progress, and ring so you never miss a single lecture. Enjoy the video. In physics, classical mechanics is a theory that describes the effect of forces on the motion of macroscopic matters and bulk objects and bulk matter, without considering quantum effects and without incorporating relativistic effects of either. It is used in describing the motion of objects such as projectiles, parts of machinery, spacecraft, planets, stars, galaxies, deformable solids, fluids, macromolecules, and other objects. The development of classical mechanics involves substantial change in the methods and philosophy of physics. The qualified classical distinguish this type of mechanics from the new methods of the early revolutions in physics of the early 20th century, which revealed the regions in classical mechanics. Some modern sources include relative mechanics and classical mechanics as representing the subject matter in its most developed and accurate form. The earliest formation of classical mechanics is often referred as Newtonian mechanics. Extent of physical mechanics based on 17th century works of Sir Isaac Newton and mathematical developed by Newton, Gottfried Wilhelm Leibniz, Leonhard Euler, and others describe motion of bodies under the influence of forces. Later, methods based on energy were developed by Euler, Joseph Louis Lagrange, William Rowland, and others, leading to the development of analytical methods which include Lagrangian mechanics, and Hamiltonian mechanics. These advances, made predominantly in the 18th and 19th centuries, extend beyond early works. They are, with some modification, used in all areas of modern physics. If the present of an object obeys the laws of classical mechanics known, it is possible to determine how it will move in the future and how it has moved in the past. Chaos theory shows that the long-term predictions of classical mechanics are not reliable. Classical mechanics provides accurate results when studying objects that are not extremely massive and have speeds not approaching the speed of light. Without the size of the atom's diameter, it becomes necessary to use quantum mechanics to describe velocities approaching the speed of light. Special relativity is needed in cases where objects become extremely massive. General relativity becomes applicable.